here we go. Section 2.1. So we are going to start a section on quadratics and other polynomials. Let me make sure that I can get everything in my, here's my video. All right. Okay. Most of this is a review from 3.4. However, we use a different formula for quadratic functions, which is a nicer formula. It's an easier formula than what you had last year. So that's something that you're going to want to look at. So remember, a quadratic has a high degree of 2. So this is your quadratic. And what does a quadratic look like? A parabola. So its general graph, is I'm missing some, all of my beautiful colors. Hang on. Gotta find my colors. And my, there we go. Now I can actually function. Alright, so a parabola is either going to open up, down, or you learned in Algebra 3.4 that they can open right or left. But if we're looking at quadratic functions, will a right or left opening parabola be considered a function? No, because it doesn't pass what? The vertical line test. So you should only be looking at up and down parabolas. So second power equation, that's what I was just referring to. They have a line of symmetry that is vertical for these ones because they're functions, right? And the vertex is your maximum or your minimum point. So this is all important. So let's just look at our general equation form. So let's say that I have, what's the difference between this one and this one? Yeah, the A is positive versus the A is negative. So for here, let's say that my parabola is over here. This would be my vertex, right? And for this vertex here, would that vertex be a maximum or a minimum value? Minimum. Because that's going to be your lowest value for y, agreed? Y is not going to go any lower than whatever this might be. Since we don't have hash marks, it's hard to tell. But this is going to be our minimum. So if your parabola opens up, your vertex is at the bottom, that means it's a minimum. Wouldn't this be our line of symmetry going through that vertex? And that line of symmetry is dotted. What are the equation of your line of symmetry? What equals what? What axis does that line of symmetry go through? The x-axis. So it's going to be x equals some number, whatever this number is. It's always your axis of symmetry. Then one of the ways that you can find that axis of symmetry would be x equals the opposite of b over 2a. You should remember that from Algebra 1.2 and from Algebra 3.4, right? Doesn't it also give you the x value of the vertex? Yep. Now I'm going to teach you an easier way to find the y value of the vertex other than plugging this in. I could find the x value of the vertex, plug it in for x, and then find y. That's how you learned in Algebra 3.4. You learned a slightly different way in Algebra 1.2. You learned a slightly different way in 3.4. I'm going to give you an even easier way now. You're like, well, why couldn't you just told this all from the beginning, right? Well, you have to learn things the hard way before we can give you the easy way. The way of the world, darling. Thank you.
Seems inefficient.
When I'm done. If I gave you the easy way, then you would just be doing it just to do it. You wouldn't understand why.
That's fine. That's okay.
I know you're okay with that. I, as a teacher, am not okay with that. All right, so whenever, and the other thing I want you to add on here is whenever A is greater than 0, it opens what? A is greater than 0, positive number, it opens up. So this is all for this function here. Now, question.
What if it's greater than or equal to?
If it's equal to 0, then you're not going to have an x squared. Then if it's equal to 0, you're going to have bx plus c, then won't that be linear?
Yeah.
Does that make sense? So it is not going to be equal to 0. If it is, it's not a quadratic. Good question. All right, so let's look at this one. What happens when A is negative? You might have an example like, let's just take the same exact one here. But you're right, it's going to open down. So when A is less than 0, it opens down. And then this would be my vertex here. So in this case, is your vertex a minimum or a maximum? Yeah, because if it opens down, the vertex is at the very top, and if it's at the very top, it's a maximum. And then your axis of symmetry, of course, would go through here. Still a vertical line. Still x equals some number. It's a number, not a 4. And again, this is x equals the opposite of b over 2a. And you might want to add, this is your axis of symmetry. And we forgot to add that over here. Axis of symmetry. Alright, so that's just your basics. We haven't gone into any detail yet. Any questions before we actually start graphing these? Before we graph them, I want you to think about what these shifts are or what the transformations are going to be, because we talked about them before, right? So let's look at the 6 examples below. So I'm going to blow these up. There we go. So here's example 1, part A. We have the function of x is equal to 1/3 of x squared. So our normal parabola would just look like this, right? What is the 1/3 going to do to this? Shrink it. So when I shrink it, does it pull the parabola up towards the y-axis or push it towards the x-axis? It's going to pull it down here towards the x-axis. It will make it fatter or wider. So right down here you have a vertical shrink. It gets close to x-axis. Now I'm not going to make you get, if we're just going to sketch these, I'm not going to make you be super accurate yet. I mean, I could. But for our purposes for this one, I'm more interested in, can you tell me what's going to happen? And so this is going to look more like this, right? It's going to look wider. If I want you to be accurate, I'll tell you to, label critical values. So I'll expect you to label 3 or 5 points. So what's the 4 going to do? What's it going to do? Vertical stretch, which makes it look skinny, right? So vertical stretch. It's going to move close to the y-axis. So it's going to make it look like this. It's going to pull it closer. What does C do? So this is outside the argument, right? Outside the argument, is it same sign or different sign? Same sign. So this is a shift up 2, right? And so if this is where my vertex normally was, then we're going to have to go 1, 2. Now I could ask you to start putting points in there, right? So here's some hash marks. So what would 1 be? What's 1 squared? 1 plus 2. 1 plus 2. 3. So it'd be over 1, up 3, right? And then -1, wouldn't it also squared give you 1? So wouldn't we also have 3? And then what would 2 be? What's 2 squared? 2 squared. 4 plus 2, 6. So our 2 would be up 2, 3. Here is, so put some hash marks on here. So so go 1 more to the right and, well, so it will shift. Original -3 out in the other one, but let's draw it here. And focus. So we just found the x-intercept, didn't we? So that's a critical. -1 squared is 1, -1 is 0. So that also, another critical value, -4, 0. If you recall, those are your zeros. And then I want to go 1 more to the right. I'd like to see if I could I'd like to see what my y-intercept is. So let's see how far that gets us. If I plug in 0 for x, because isn't that 0 for x? What's 0 plus 3? 3 squared? 9 minus 1? 8. Does get us very far up there, but we'll deal with it. So we're right here. And this is 0, 8. And so shouldn't I have a symmetrical point over here too? If I went 1, 2, 3 to the right, 1, 2, 3 to the left, should be up here at negative 6, 8. Look at this. Five points will generally give you a nice shape. All right, look at F. Let's talk about what's going to happen here. Let's talk about the shifts. What direction is this going to shift it? So we've got up 2. What about this shift inside? To the right 1, opposite direction. And then reflects. So this is 1, this is 1, this is 1. Over x-axis, y. Because of the negative outside the argument. And then what does the 3 do? Vertical stretch. Big is a stretch, small is a shrink. So this is a vertical stretch. So I anticipate that it will get closer to my axis of symmetry. I can't say y-axis this time because it's really our axis of symmetry because our vertex has moved. So let's put in some hash marks. So my original vertex was right here. So with my shifts, I'm going to go up 2 and to the right 1. So there's where the new vertex is. Because it reflects over the x-axis, I know I'm going down. And because of the stretch, I really need to plug in points. So here is my axis of symmetry, because I want to see what it looks like. I anticipate it should stretch close to it. What is the equation of this axis of symmetry? What axis does it go through? X equals 1. So this is x equals 1. Because it goes through the x-axis at 1. Alright, so choose a point to the right of my vertex, so it would be 2. So plug in. What's 2 minus 1? 1 squared? 1 times negative 3? Negative 3 plus 2? Negative 1. So to the right 2, down 1. So I'd label that point, label your vertex, which is 1, 2. And then let's plug in a number to the left. To the left, same distance would be 0. So it's 0 minus 1, negative 1 squared, 1 times negative 3. Negative 3 plus 2 is still negative 1. So we're right here. Isn't that our y-intercept? 0, negative 1. And I want to choose one more just to show you that it's getting close to our axis of symmetry. So let's choose 2 to the right. So that's 1, 2, 3. What's 3 minus 1? 2 squared. 4 times negative 3. Negative 12 plus 2. Negative 10. So it's going to be over here, but it's going to be way the heck like down here, won't it? Do I have room on my graph to plot that? Not really. So with my stretch, I really ran out of room rather quickly. So I'm going to go ahead and leave it with these 3 points, but make sure that you make it look skinny, because you know it's going to be skinny. Questions on how to do that and how accurate I want you to be. Okie doke. Alright, so flip it. You have a question? Question. Yes, sorry.
So, just for sake, even if our all of our points show that it's mean, if we don't draw its mean, so are we gonna get in trouble?
Well, if you plot your points accurately and you label your points like we just did, you're gonna be fine. So I wouldn't worry about that. Sometimes can I get 5 points with a vertical stretch? Yes, especially if we had moved it up further, more numbers down this way. Does that make sense? Okay. All right, so let's look at example 2. Now, this is my favorite quadratic form of or standard form of a quadratic. Little different. I believe in algebra 3-4 you had like y minus k equals a times x minus h squared. I believe you had your k along with the y. But because we deal with functions in pre-calc, we want f of x by itself. So we move the k to the other side. What's nice about that is outside the argument, isn't it the same sign? Okay. Inside the argument, it's what? Opposite sign. And the other thing that we've noted here is remember that your vertex, if you have it in this standard form, you can read your vertex right off of that. Isn't that what we've been doing? This is your shift up or down, and this is your shift right or left. That's going to tell you what your new vertex is, correct? So if you have it in standard form, which a lot of our equations have been so far, you're going to be able to see your vertex without having to calculate the x value of the vertex, which we said was the opposite of b over 2. The problem is, how do you get in that standard form? Look at what I've given you here. Is that standard form? No. And the directions say identify the vertex of a quadratic function and graph. Using algebra, no calculator. So if it says use algebra, you best not use your calculator because you're going to have a calculator portion to your exams and a non-calculator portion. So you need to be careful with that. Could you check it on your calculator to see if you did it right? Yes, absolutely. So, what do you think we might do? How do we get something like this from something? How do we get a nice, isn't this a nice perfect square? How do you get a perfect square from a quadratic? Remember completing the square? Even better than factoring. Remember complete the square. Oh, all right. Are you ready? There's a couple ways I could show you to do this, but let's just start here. So first of all, when I complete the square, can I have a coefficient from the x squared? No. So the first thing that we have to do is get rid of that. So write yourself a note. First of all, we do know that this parabola opens what direction? Just looking at it. What's A? Positive 2. And so since it's positive, it does open up. So I know that right away, mostly is greater than 0. I also know what the y-intercept is just looking at this quadratic. What's the y-intercept? Repair, what would that? 0, 7. Whatever the constant is, whatever c is, that's your outside of standards quite easily. Then we are going to make a perfect square by completing the square. Now this sometimes gives you an ugly kind of thing. So the very first step is to factor out that 2. But we're not going to factor it from the 7. We're going to cut it off right here, and we're just going to look at these 2 right here. So if I factor 2 out from the first term, what do I get? 2 parentheses x squared, and then divide this by 2, I get plus 4x, and then plus 7. Right? Mm-hmm. Then I'm going to have to complete the square. So to complete the square, I've got to do 2 times x squared plus 4x plus a blank. But remember, this is an equation. If I add something to this side of the equation, well, I normally would add it to the other side, but we don't want to add anything to. So don't I want to add a value of 0? Right? So whatever I add here, I'm also going to subtract. Because I want it to be a value of 0, and I'll show you how. Plus 7. Oops, sorry, I didn't mean to jiggle it. So then we're going to complete the square. So over here, remember to complete the square, look at, now that this is a coefficient of, you always take that middle value, you take b, isn't that our b, divide it by 2, and square it to get our new c. So in this case, we're going to take 4, divide it by 2, square it, and don't I get 2 squared, which is 4. So I want to add 4 and subtract 4. Doesn't that give me a value of 0? Well, here's the deal. Do I want the minus 4 in there? No. In order to get the minus 4 out of parentheses, what do I have to do first? What's in front of the parentheses? Yeah, so I have to multiply the 2 to the negative 4 first. So here's what I end up actually having. 2 parentheses x squared plus 4x plus 4 end parentheses. To get rid of this, I really have a what? Negative 8. So then minus 8 plus 7. Now, this should be a perfect square trinomial. 2 parentheses squared, and what do these give you? Minus 1.
Is it x plus 2?
Yes, why is it x plus 2? Find the square root of your bookends. What's the square root of this? X. What's the square root of this? 2. And then whatever your middle sign is, in this case it's positive, it goes in the middle. So isn't that now in standard form? It took me a while to explain it, but normally it goes much quicker, doesn't it? So now what's your vertex? Just looking at that. So number 1, your vertex. So what's our x value of the vertex? Negative 2. What's the y value? Same sign, negative 1. Outside same sign, inside opposite sign. So we now know our vertex, so let's go up and plot that. 1, 2, 3, 4. Put in your hash marks. I'm going to immediately put in my axis of symmetry because I need that for visual. It's dotted because it's not part of our graph. What is the equation of this? What's the equation of that axis of symmetry? X equals negative 2. You have to put that in there. Then they've asked for the vertex. They've asked us to graph it. So I could graph it doing what? Well, first of all, what do we know that this 2 does to it? It's a vertical stretch, right? So we know we have a vertical stretch. So I should expect that it's going to be closer to the axis of symmetry than normal. What is that vertex a maximum or a minimum value? Is it at the top or the bottom if my graph opens up? It's at the bottom, so what is it?
Minimum.
So our minimum value is going to be equal to what? Minimum value is what? Is it the negative 2 or is it the negative 1? What's restricted, your x or your y? Can I choose any value I want to for x? Yes, I can. So x is not restricted. Abby. Abby, wake up. So y is restricted. Where is it restricted at? Negative 1. This is the lowest y is going to be, isn't it? That's why it's our minimum. So our minimum value is negative 1. So that's going to kind of help you with your range restrictions. All right, so let's go ahead and plot. What do you want to plug in? Okay, we could do our y-intercept. We know our y-intercept is 0, 7, right? 1, 2, 3, 4, 5, 6, 7. And that's a really good one to choose. And that's 2 away, isn't it? If we go 2 away on the other side, shouldn't we have a symmetrical value also at 7? Will that give us a decent shape to our graph? Yes or no? Yeah. And what I want you to get in the habit of is if your vertex is below the x-axis, you need to get points that will extend it over the x-axis. I don't need you to have to find these values exactly if you found these. For right now. Later we're going to find the zeros, but not today. Although I could find this by using my calculator only, right? Since it's a no calculator problem, we're not going to find the zeros on this one. All right, so have I done everything they've asked me to do? Yep. Did it turn out the way we expected? Yeah, it's a semi-stretch shape, isn't it? Opens up. All right, look at the next one. See how it's different. Write the quadratic function in standard form. So isn't that the same as before? State the intercepts, the vertex, and then the graph. Here we go. You ready? What do you know about it right now? Okay, so it opens down. So the y-intercept is 0, -8, right? So I know that just from the get-go. All right, so let's find our standard form. What do I have to do first? I have to take out the -1. So I am cutting it here, right? So I'm going to factor out a -1 or just a negative. And that makes it x squared minus 6x. And if you want to, right here, you can do plus a blank, minus a blank. And then the -8 does not change values. We are not taking out a negative from the -8. Then we want to complete the square, right? So our new c is equal to b over 2 squared. So -6 over 2 squared is -3 squared, which is 9. So I want to add 9 and subtract 9. But I need the -9 out of there, don't I? So I have a negative x squared minus 6x plus 9 and parentheses. How do I make this go away? What's -9 times a negative? So it becomes a positive 9 minus 8. So keep going. Negative. This should be a perfect square trinomial now, squared. So the square root of x squared is what? X. We're so happy in Spanish class. And then your middle sign is a negative. Square root of this bookend is 3. And then what is 9 minus 8? Plus 1. So we have f of x is equal to x squared plus 1. So now they want the intercepts. Well, we found one intercept. We'll see if we can find the x-intercept. So we found the intercept. What's the vertex? Our x shift is what? What's our x value? 3. What's our y value? 1. Inside change the sign, outside keep the same sign. So for our vertex, we get positive 3, positive 1. So I would actually plot that now. And so we know it opens down, so I'm going to put it here, 3, 1. And here is my axis of symmetry. What's the equation of this? X equals 3. All right, then the other thing, I know that one of my intercepts is 0, -8, right? So this is 0, -8. It's hard to see. So how far away is that? 1, 2, 3. So I want to go 1, 2, 3 to the right and go straight down. And this would be my other symmetrical value, which would be 6, -8, right? So did I get my x-intercepts? No. How am I going to get those? If I asked you to do it algebraically, how would you get those? Well, what value on the x-intercept is 0? Okay, what's this ordered pair right there? 1, 0. What's this ordered pair here? 3, 0. What is always 0 on the x-axis? Y. So let's take the original equation, not the one that we found, but the original equation, and we are going to let y, the f of x, be 0, and then we have negative x squared plus 6x minus 8. How do you normally solve that? Factor. Do we like to factor when x squared is negative? No. So if I were you, I would divide this by -1 and this whole side by -1, which means every single term on the right side changes signs. So I end up with 0 equals x squared minus 6x plus 8. Are there any factors of 8 that add to give us 6? -4 and -2. Do those add to give us -6? Do they multiply to give you positive 8? Yes. Then set each one of those equal to 0. And what does x equal? Here? 4 and, so 2 and 4. So our x-intercepts would be 2, 0 and 4, 0. So let's make sure we hit those. Here's 2, 0 and here's 4, 0. Did I inadvertently hit them anyway? Yes, and we better label them. 4, 0 and 2, 0. Could you plug this into your calculator, this expression right here, and check that? Yes or no? Yes. But if I asked you to show me algebraically without your calculator, I'd have to see this. I'd have to see the factor. All right, so any other questions about this? Are we surprised that it reflected down? Because we knew it opened down, right? Okay. All right, so flip it. Last question. Flip it. It sounds like I'm swearing. Flip it. Darn it. Oh. Devo. Bum 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 bum. Right. Crack that whip. Flip it. So you ask your mother if she remembers Saguaro High School's talent show. There were some boys that did Devo with the whip it. Loved it. They had the little red caps on and everything. Yep, it was fabulous. Let me finish this and then we can chat. All right, so we're going to find the equation of a parabola in standard form. So look what they've given you. It had the vertexes 1, 2. So what are they actually giving us? Which is H and K. Inside the argument, outside the argument. And then it passes through the point of 3, -6. Well, let's start first of all with our general form. F of x is equal to a parentheses x minus h squared plus k, right? That's your general form, correct? Well, let's plug in what they've given us. What is this point going to give us? X and y. We actually have an x and a y in here. We have an x here, and isn't f of x our y? Okay, so we're going to replace the f of x, which is our y, so this is step 2, with -6 equals, we don't know a, right? But we do know that x is 3 minus, what's our h? So this would normally say -1 in here, wouldn't it? Because isn't this a +1? So that makes sense. Squared. And then plus, our k is 2, same sign out there, right? So what's left to solve for? That's all we're solving for is a. Because that's all we need is a for our standard form. If they've given us our h and our k, all we really need is what's in front of that parentheses. Okay. Yeah, but it looks like you are. All right, so then go ahead and solve step 3. So I've got -6 is equal to, first thing I'm going to do is do the math here. So I've got 2 squared plus 2. -6 is equal to, 2 squared is 4, so I'm going to write it as 4a plus 2. Subtract your 2. So I get -8 is equal to 4a. Divide by 4. And don't I have a equaling negative 2? Does it make sense that a is negative? Look at the graph that they showed you. It opens down. So now I can actually find my standard form. All I have to do is go back up here and replace the h, the k, and the a. These are the three that you replace. Everything else remains the same. So f of x is equal to negative 2 parentheses x minus 1 squared plus 2. So that's actually a lot easier, isn't it? I'd rather write standard form all day long than have to graph the parabola, wouldn't you?